Okay, I'm on my IntelliJ, and let's solve this problem here by the algorithm that we developed here, this 2D array. So I will take this method name here. Okay, I will mark it as private static because I just use main class to call this, and we just called minimum distance of. Okay, I will take both the examples. Start with horse and rose, and also let's take the second example as well, so that at least these two examples are correct by the solution that we created in the last video. I have a habit of making it final to make it immutable. We should never mutate any parameters or arguments passed in a method. Okay, let's go back here. So we have to create this 2D grid and keep on calculating these numbers as we go from here to here, and this would be our final solution. So let's try to implicate this into the same, implement it into using Java. So let me first of all take the length into a final variable. And word2. Now here I see one condition that the length can be of length 1. The words can be of length 1, of 0, sorry. So we have to check for this base condition. Say, for example, if say word 1 is of 0 size, which means it's empty, it means that whatever the length of word 2, so we have to insert all those numbers, all those characters to make it null, or we have to delete everything from this. So that's why it should be the word2 dot length, and vice versa. If word2 is empty, which means that we have to delete everything from word 1. So the number of edits would be the length of that word 1. So let's put this condition here. If m is equal to 0, then just return n, right? Because we have to insert whatever the characters are there in the second string. Similarly, for if it's n, yeah, we have checked for this edge case. Now let's create our 2D array. I'll call it as db and new int. Now here we have seen in this, it should be length plus 1 for this terminal condition, and also for here should be one extra, the length plus 1. So it means that it should be m plus 1 and plus 1. Okay. Now let's iterate from here till here. We have to start from the 0th. For I is less than 0, and because we are taking here this, I take similarly for j is equal to 0, which is the word 2, it should be equal to n, right? This is for columns. Now let's first of all fill on these terminal columns and row, this one. So here we can simply see that if I is equal to 0, I mean if the row is the first row, this one, talking about this, if I is equal to 0, in that case we just fill the first row, all the columns as whatever is the j, or the column number. So say for example, here this I is 0 here, and j is 0. So the dpij is 0. Similarly, j here is 1. That's why we put as 1, 2, and 3. Right. So similarly, I will fill this part now. If j is equal to, so that is the first column, then in that case, dp of ij, that is for all the rows in the first column, should be I. So in these two conditions, I have filled the first terminal row and column. Now let's go to the actual algo. Or I think I should use else if here, because we have to either use that or either use the other one. We can't use both at the same time. And now we go with the actual algorithm that first start with, if the word one, the easier part, if the character match. Sorry. One dot char at I minus 1. We are using I minus 1 because the array starts with 0 character, so it means that we are just moving to this part here first. If this is equal to word2 dot char at j minus 1, then in that case, dpij should be whatever was there in the left upper corner. For example, O and O, this cell, we are here because these characters match. It means that we have to pass this value, whatever the value is here, to here. We simply copy it. So it should be dp I minus 1 j minus 1. I minus 1 is this, j minus 1 is this. We just copy this value to here. Or the last condition is if they don't match, and just remove some extra space, and else just copy this, dpij is equal to 101 plus. Now we have to find the minimum. Suppose we are at S and O, this cell. We have to find minimum of this, this, and this, and add 1 to it. So minimum was 1 here, we added it here. 2. So in Java, we can only pass 2 arguments. We can't pass all the 3 arguments. So I will do like this, that I will take minimum of, say, dp I minus 1 j minus 1. Minimum of this I minus 1 j minus 1 is this cell. And because we can only take 2 arguments, that's why I will take another math.min, and then I will find out whether it's I j minus 1 I minus 1 j. That's it. So dp I j minus 1 is I the same and j minus 1 is this cell, or I minus 1 j is I minus 1 is this, and j is the same column, so it should be 3. So we have found the minimum between this, and added 1 to it. This is what we have derived here in this formula of reach to d array. Now once we have done all this, here's our ends. Then we need to simply return this last. Now, yeah, our whole algorithm has been written. It's a very simple algorithm, as you see. It's just this part where we have all this. Basically, mainly this is the two steps which are the most important as a part of our algo. Now let's run this. Okay, so we got 3 and 5. So for horse and Ross, it was 3, and intention and execution was 5. Let's match it here. Yeah, it's 3 and 5. Okay, now let's copy this here and then see whether it's good or not. So I'll just copy this whole solution, put it here. LeetCode is a very good platform. I always recommend it because it just removes all the noise and we can just implement the algo here. It has got so many languages to use. So let's run this code. It will cover all the edge cases, test cases. They have got many test cases to check the algo. So let's do it. Okay. So the solution works. Now let's go for the space and time complexity. Here again, we see that we are creating a 2D array. So the space complexity would be m into n. M is the length of word 1 and n is the length of word 2. Similarly, for the time complexity, it would be same as well because we are using 2 for loops, iterating through it, and then calculating the value. So would be O of m into n. So that's it, guys, for edit distance problem. I think we have solved this problem in a very easy bottom-up approach. And we have covered 4 problems so far in this tutorial series. In the next video, in the next problem set of videos, we will solve a very easy problem called as climbing stairs. But I think this is, again, one very popular problem of dynamic programming. And understanding this problem will help to understand the concepts of how to approach a problem using dynamic programming bottom-up or top-down approach. So see you all in the next video.